Srilamam, shall we proceed with the session?
Yeah, we'll start this first
Okay.
session.
Praveen sir, if you have any presentations, you can
Yeah, I have.
share it. One second. Anju. Okay, you can start with the session.
Yes, ma'am. Mr. Praveen is a seasoned architect with 25 years of experience in the technology and IT sector, including 2 decades with IBM. He has demonstrated a strong expertise in cloud computing over the past 10 years and has built a reputation for leading and mentoring teams in a variety of technical roles. He is one of the enablers of IBM Watsonx platform to Kochi IBM employees, which is IBM's next generation AI and data platform. Currently, he holds the position of Technical SPOC at the IBM Kochi Development Center. Throughout his career, Mr. Praveen has had the opportunity to work across multiple locations in India and internationally, which has allowed him to develop a broad understanding of global enterprise needs and technological solutions. Mr. Praveen is passionate about sharing his knowledge. He has conducted numerous technical training sessions and acted as a mentor to many associates within IBM, helping them to grow professionally and succeed in their roles. His expertise and key areas include cloud computing, enterprise architecture and solution design, leadership and technical mentoring, training and professional development, etc. Welcome, sir, for this session.
Thank you. So shall I present my video? I mean the PPT?
Sure, sir. You can start with the presentation.
Okay. It's asking for the permission. Okay, so let me try again.
Sir, are you able to?
I'm getting echo.
Sorry, sir. We have added you as card host, so
I am unable to share. Okay, share my screen.
yeah, it's coming, sir. I think.
Okay. So you see my screen, right?
The presentation is not yet visible. Oh yeah, we can see the screen, sir. You may proceed with the presentation. The entire screen is presented, I think.
Yeah, that's what I was looking for. Where
Okay.
I can see, share only the.
That is while sharing itself, you have an option, share window.
Yeah, present something else. Stop sharing. Okay.
So when you try to share, there are 3 options. Window, share window option is there in the middle as the tab.
1 second. This is something blocking. Select window.
While the presentation is getting ready, please, I request all the participants to stay in the meet itself. And some have extended a consent, right? They have joined from other mail IDs. We'll be tracking attendance anyway, and we'll sort it out later.
Is it still the full screen or?
It's still the full screen. Sir, can you take the presentation?
Do you see I'm already sharing my presentation? Do you see it? You're not, right?
No, sir. Sir, when you click the share screen.
Yeah, it is giving allow Meet Google to see your screen, select window or screen. Okay,
Window.
now
In that
it is
window?
coming.
Yeah.
Now it is
Okay.
coming.
Okay, sir.
So there was something was not really permitted. Okay.
Okay,
Anyway, I
okay.
think now it is working. Do you see?
Yes, sir. Yes, it's fine now, and we can see the screen.
Okay. You can also see me, right?
Yes, yes, certainly.
Okay. So I think, you already gave an introduction about me. I don't need to talk about me. So I'm still in office. I'm working, but, we'll go with, the talk. Okay. So these are, the first slide, basically, these are the discussion points. What we are going to discuss in the coming 1 hour or so. These are the discussion points. Basically, we'll start with the introduction to the supercomputing. And then we'll talk about, the high performance computing, and we'll also, talk about, what supercomputers and supercomputing. When there is a, we'll set the context basically. There could be a confusion for the people, like, are we going to talk about the supercomputer? Are we going to talk about the supercomputing? Because, it's all about supercomputing and AI, right? Then we will talk about how does the supercomputing is really work, what is its high level architecture, what are the key core components of supercomputing, and then then we'll get into the AI part, how the supercomputing is really related to the artificial intelligence, where exactly how exactly they are related, that we will discuss. And we will definitely touch upon some machine learning, deep learning, neural networks, basically from those, we will go into the latest, the dominating architecture of neural network, basically the transformers model. And why we are talking all this, because where exactly this AI comes into, the supercomputing is coming into the AI. We will come to know when we talk about this model. Then we'll touch upon the LLMs and the transformer architecture I mentioned, the model training. That is where really require the power of supercomputing. And then we will also talk about some of the benefits of supercomputing. Then there are some advanced topics, like if time permits, we will talk about the generative AI, agentic AI, where it's a kind of where the the supercomputing is used, or I would say the byproducts of supercomputing. We have supercomputing, and where exactly we are really using it in the the nowadays, that kind of a discussion we can have with the Gen AI and agentic AI. We can talk about agentic applications, MCP, orchestration framework. I think that those are advanced, but not 100% related to this topic of supercomputing and AI. But we can, it would be good, if we discuss about that, people will get some, some more understanding, will get some knowledge about all this, the topics or the AI, the type of AI nowadays we are using. Even the type of application nowadays the IT companies develop, those are all related to the generative AI and the agentic AI. Even the Gen AI is now gone now into the agentic AI. Okay, so we can talk about it. So let's get into. Are you all okay with this topic? I mean, do you think that this is going to get benefited? Can you show a thumbs up? I hope I don't see anything, any thumbs up. Okay, so just want to understand all these points. It's a kind of the path that we are going to follow in this discussion. Let's get into the topic. So what exactly is the supercomputing? So we are talking about powerful computers. Are you all able to hear me? Am I audible?
Yes, sir, we can hear.
Okay.
Yeah.
Okay. So we are talking about, when we look at the high performance computing, we start with we will go into the supercomputing, but before that we need to talk about the high performance computing. Even I have seen that this topic is there in the coming days. Somebody is going to talk about it, but I'll just touch upon on the high performance computing. It's all about powerful computers that we are talking about, right? So when we say powerful computers, it is about when we relate it with artificial intelligence, or a massive data analysis, or some of the use cases we talk about, we'll talk about where we need powerful computers with all, which also has a parallel processing. So, basically the parallel processing, if you look at any our computers in the Intel computers or AMD computers, it has CPUs. It is also can do parallel processing, but that is not really the intent of those computers. So though they can run, they can do the parallel processing, or it can there are threading that can process multiple processes. I mean, the multiple tasks that can parallelly do. But if you look at a supercomputers, where we are expecting a parallel processing, in the sense thousands of millions of tasks are parallelly running, which is very much required for the type of use cases that we are looking for. So we are talking about powerful computers which can really have the parallel processing capacity, which is really used for a large complex workload that we want to execute, where it comes this high performance computing usage. But if you look at a supercomputer, it is only a subset of the high performance computer, or I would say in the supercomputing world. If you look at supercomputers, these are definitely high performance, extreme computation. It has extreme computational power, but it is only about what I'm saying is, if you look at the point that is mentioned here, every supercomputer is a high performance computing, but not all HPC systems are supercomputers. So supercomputer is the biggest, the the extreme, but we can also have less powered, not super power, but having very high powered computers that can also be part of HPC. Okay, so supercomputers, again, the physical machine built for extreme computational power. And if you look at the some of the points, it has thousands of CPUs and GPUs. So we know that what is CPU, what is GPU. See, the GPU is a graphics processing unit. Okay, so GPU, basically the idea of why we developed or designed a GPU is mainly for the graphics processing. But that was the main intent. But this the nowadays in all the supercomputers, CPUs and GPUs and even the TPUs are used for having that the extreme or the highest computational power. So we have thousands of such kind of CPUs and GPUs, and specialized. If you go into the other components of the supercomputers, we have interconnects, we have massive memory. So we'll come to those points. Anybody has any questions? If you're not talking, can you go on mute, please? Okay, thank you. Okay, so every supercomputer is HPC. I just repeat the same sentence, but not all HPCs, high performance computing, is not supercomputers. So supercomputers are mainly focusing on the hardware and the architecture. We'll come to that. So Frontier, you have some examples here. Frontier is one of the most popular or the number one supercomputer which has exascale, I would say, the computing power. So it is one of the the first verified exascale supercomputer, and which is built by HP Enterprise. That's exascale. Similarly, IBM Blue Gene, you can see there is another example. That is also one of the supercomputer. Yeah, so that's from IBM. It's actually help biological observation. So basically, it is used for the protein folding. So that was it has almost more than 65,000 computing nodes. So we might be thinking about what is a node and all. We'll come to that. Just I'm just giving a high level idea about that. These are some of the supercomputers that we have. IBM Blue Gene is one, and the Frontier. These are having that supercomputing power. And when you look at the supercomputing, not the supercomputers, the supercomputer is all about how we use it. So we have that extreme power available, but where are we going to use it? And when we use it, we call it as basically the supercomputing. So we are using or processing that extreme computation power. That is nothing but the supercomputing. So supercomputing is achieved. I mean, all the hardware that are associated to supercomputers. We talk about the computer or computing, or if you look at the memory, or if you talk about the storage, or if you talk about the networking, all that the specialized architectures, all that in a combination. If you make use of all that, then we say that we are actually achieving or implementing supercomputing. So there are some of the applications mentioned here: the scientific simulation, the climate genomics, training large scale AI models. So if we can even think about the climate. Okay, so is there any question? Just before I proceed, is it the context is clear that what is a supercomputing, and what is the difference? And is it the same like supercomputer, and what is really the HPC, high performance computing? Is it clear, or is it okay? I can proceed.
Yes, sir.
Okay, I assume. Yes. Okay. So I mean, we can take an example of the climate modeling. I hope people might have heard about the climate modeling. Climate modeling is one of the very simple or very easy to say, or the most matching example or the use case for the supercomputing usage. So can you go on mute, please? So Earth's climate, it's when we talk about climate modeling, what exactly it is? Earth's climate is it's basically we look at the climate data or the modeling you are going to use, or you are going to analyze the climate of Earth. It's a large grid. It's if you take if you make the Earth as a big grid, and you look at the different types of data that we need to analyze, whether it is a rainfall, whether it is the cloud formation, or if you talk about the temperature, pressure, wind, anything. If you want to simulate that, it's a huge data. You can see that you get it from the the satellites. You get it from the stations in the Earth. From the different places you get the data, and there are so many sources from where we get the data. And if you want to simulate it, why do you want to simulate it? You want to simulate it because you really want to make a climate model that can use for different purposes, right? See, basically the purpose, if you see climate models, it'll help us figure out which regions are most vulnerable. I mean, there are areas where we have there is a chance for some calamities, so climate impacts such as droughts or floods. So if you want to get some sense out of the climatic data, you need to to use those information and do the simulation. Then only you will be able to to make use of it. So so if that comes, there are policymakers, or there are international what do I call it, authorities. They might want to make some policies like green energy, or we have so many policymakers around, right, in the world. So they are actually utilizing this climate data, and the question is, how are you going to do this simulation? Because it's a huge data. It's not a small data that you are going to simulate. So in this situation, definitely a supercomputing power, which will definitely help them to simulate. Because if you're doing it with a laptop, you get the data. I mean, first of all, you need to have the high-end storage to store the data, and then you require the computing power to simulate, or to process that data. And that processing, again, you can think about you have a processor. That processor will process only when it gets the data from a memory. And how the data comes to memory, it is again some storage. So storage has some speed, processing speed, and it comes to the memory needs, sufficient memory is required, and then again it reads by the processor, and then there is a processing happen. So if everything happens in a faster manner, then only you will be able to to get or to generate, or I would say to you will be able to come up with a climate model within the time frame. It is not about you are making the climate model in the in 100 days, right? So you want it to be completed, or you want to create it in a day or a 2 days, and not 10 years or 20 years, right? So basically that computation power is very much required, and where exactly the use of supercomputing comes into picture. Okay. So how does it work really? If you look at the diagram, so it's copied from internet, so you can just make out that there are it's all CPUs mentioned. There could also be GPUs, but you can see that there is a big box. There are three big boxes where you can see there are small boxes which is talking about these are actually the CPUs and CPU core, and each of the CPUs might have processors, and you have multiple nodes here. All these nodes are interconnected. Okay, I'll just take this pointer so that you understand. Okay, so you have the data stored. There is a storage. You have memory in each node. So this is a structure. You might you need to understand this is a cluster. Okay, so this is a cluster, and this cluster you can have thousands or millions of processors, which can be CPU or GPU, and they are organized into interconnected nodes. So basically these CPUs, again, they are interconnected. So you have a logical grouping of all the CPUs in the node 1. You also have a grouping of grouping in a node 2 and node n, and they are all interconnected. So when we say interconnected, it is not a simple connectivity like the Ethernet connection or the normal networking that we are talking about. It is high speed internet internal networks. So you can see that there is something InfiniBand is mentioned. It's a it's basically InfiniBand is a I would say it's a kind of a it's a basically a standard. It's a standard which is high speed computer networking standard designed for high performance computing. So that's the definition of it. It's a high speed computer networking standard designed for high performance computing. Okay, so the advantage would be when we have that that standard and that high performance, when we talk about, which will have high throughput and extreme low latency. So that is required, right? Because we are looking at you're looking at the thousands or millions of interconnected, the processors that are interconnected, and it is all why we are what is the key factor of all this? Basically the parallel processing. As I mentioned earlier, even the supercomputing, it is all about the high performance computing. It is all the key motive is to have the parallel processing, because thousands of people solve a puzzle at the same time. You can have see at the example, like if instead of sequentially doing the work, thousands of people are solving a puzzle at the same time. Basically what it means, you will be able to complete on time. The same case that we saw the climate modeling, if you do it in parallel, then only we will be able to complete on time. So it's a parallel processing, and that is one thing. And in order to support that parallel processing, you have thousands of millions of processors, and they are all interconnected. They are all grouped in nodes, and nodes are connected with high-speed network, InfiniBand. It actually guarantees low latency and high throughput. You can make out from that definition. And there is also very important factor here. You can understand that there is a storage, right? The storage, a normal storage. When I say normal storage, they are all following some file system. So GPFS is a general process file system, general parallel file system, not process, general parallel file system, which is again an invention from IBM. So basically it has special capabilities. It has the DMA, the direct memory access. So basically a file system, not like a FAT file system or a NTFS file system or a ext4 file system, which is a Unix or Linux based file system. We have FAT, I think a FAT32 we have used long back, and in Windows we use the NTFS file system. Those file system will not really help us, to have that, parallel processing. We require a special storage, special file system which is similar to GFS. There are even more, but I'm just taking an example of general parallel file system, which is actually helping us to have that parallel processing. Okay, so this is a high level, the architecture of supercomputing and how it is really achieved. And this achievement is all based on these core components. Okay, you have the parallel processing, you have a processor cores, we talk about the CPU, GPU. I mean, again, if you look at the GPU, parallelism is supported. We cannot say that your CPU, your Intel processor, the Pentium 5, it is not multitasking. You cannot say that. It is multitasking, but it is not that extent that we are looking for. Okay, so you need extreme parallel processing where you require GPUs or TPUs, which is, I mean, GPUs, if you can see, designed for graphics, but it is really, nowadays used for the artificial intelligence and HPC. Okay, and where exactly in the AI, that will come to that. Okay, so it has the nodes, as he said, it has nodes, and then the interconnect. We talk about another example, that InfiniBand, in order to communicate. So all these lines, okay, it is connecting, or this connectivities. That is, we talk about the interconnect, and then we have the massive scale, the storage. I mean, it's all about the massive scale, right? It can consist of thousands of nodes, millions of processors. Basically, we are all talking about in a massive scale. It's not just a few hundreds. It's not that intent. So specialized architecture. So it can have its own memory. It can even have a memory which is shared with the other processors. So that's something called the SMB and MPP. So massively parallel processing and symmetric multiprocessing. So just for the awareness, I have included. But the point is, we have a specialized architecture, and when we do this kind of a power consumption, this kind of a processing, it definitely generate heat, and that in order to make the system stable, we need to have that cooling system that is also part of the supercomputing. Okay, so then the storage and input output, this is again that, as I talk about, it requires, you need a standard or supporting multi-processing or parallel processing storage or parallel file system that we require. And we also need a mechanism which will not really interrupt the CPU. You can see that the DMA, which is mentioned here, it's basically the DMA is the direct memory access, and the DMA controller, which is actually helping us, to have that parallel processing. When I say parallel processing, you can see that how DMA is working. CPU is only interrupted when the data movement is completed. So basically, how much data to be moved, that instruction comes, the CPU tells the DMA controller, and it forgets. Okay, DMA tells, okay, CPU is telling the DMA, okay, move this much chunk of data to be moved from here to there, and then the CPU is going into his own world. Okay, it is doing its work. It is not really interrupting. Nothing is really interrupting in the CPU. So until that, the data movement is completed, the CPU is completely isolated and it is doing its own work. So that kind of a architecture is basically helping a supercomputer or supercomputing to be really working. So, okay. So now the question is, where exactly the supercomputing is linked to artificial intelligence? So, okay, I'll just take a pause. Is it all okay? I mean, any questions? Anybody want to ask something or to add anything? Any questions?
Sir, there are two persons who raised their hands. I think they have
Yeah.
some queries.
Sure, go ahead.
Miss Sunitha in Chennai and Delmi David. Is there any queries? Please ask to sir.
You can unmute and you can ask. Okay.
So I think they raised their hand by mistake.
By mistake.
They
Okay,
can
no
continue.
issues. Okay, I'll just proceed. Okay. Okay. Okay, so then if you look at we talk about we talk a lot about the supercomputing, but the interesting area is the artificial intelligence, right? I mean, the artificial intelligence, how exactly they are linked. Like if you think about the machine learning, people are all aware of what is. I think everybody is aware of what is machine learning. At least the initial part of the artificial intelligence. People must be knowing like the machine learning. That was basically making the machine learn, right? I mean, so it can mimic the human, right? So that is what basically we talk about artificial intelligence, and the machine learning is the earlier days, I would say, the traditional AI or the earlier days of AI, right? So we were actually using the machine learning systems. If you think about the disease diagnostics, or if you look at the example, like you are getting a mail, and that mail might be a spam, or it might not be a spam. So that kind of a classification, okay, this is a spam mail because I identified based on these factors, right? So those kind of use cases were implemented long back when we were doing the machine learning, simple machine learning. I mean, machine learning is still there. I'm not saying that it is not used, but the way it was utilized earlier, the way it was trained earlier. So it was supervised learning and the unsupervised learning, reinforcement learning. So now basically all that kind of all that learning, or at the training, I would say, it was not that complex. That's a point. I'm not going into the machine learning or deep learning. I mean, I'm not going to explain that, but my point is, when we look at the machine learning, and then from there we landed onto the the latest, the what is the trend now. It is all about the architectures. It is all about the architecture, right? So from the machine learning we now move to the deep learning via neural network, right? So neural network is the key invention of AI nowadays, right? That's a trend, right? So basically these are all different architectures. So transformers is also an architecture, that follows, basically that is following the neural network architecture. So deep learning via neural network, and transformer is one of the architecture that it follows this neural network. It's not the only one. You can even think about the current, what is it called, the CNN, or the it's a difficult English word, convolutional neural network, CNN, and the recurrent neural network. These are also the architectures that are following the neural network, but the way they are working, the way they are designed, that is different. Right? The transformers can actually transformers are following. There is something called self attention. So you can see that there's a self attention. So what I'm trying to say here is, when we look at the transformers architecture, where we have the models, the transformer, what are the models that are coming out of this architecture with GPT? So we have the chat GPT, right? So chat GPT is a chatbot, but internally it is using the brain, which is nothing but the models, right? So the large language models, the GPT, and then GPT, now it is 5, I think. In the 4 is done, and now it is GPT 5. But similarly, we have BERT, we have Granite. So just for your information, the Granite is IBM model, and then Llama. So these are different LLMs, the large language models. And when we talk about the large language model, why we call it as a large language? Because it's a large, because it is working on huge number of parameters. So we slowly we are getting into the AI. those who already know that it would be very easier for them, but it would be a bit difficult, for the others who never touched on the AI. But my point is, we have the transformer architecture, and and it is actually working on a huge number of parameters, and those parameters are the I would say the learning, right? So basically, if you look at this model, GPT model, and how they became so intelligent, only because of the training. Similar to the people go to college, people go to the education institutions, they go through the study and they become intelligent, right? So they read a lot of documents, all the the books, they get the knowledge. Similarly, when we train these models, which are following which are following the neural network architecture, or I would say the transformer architecture. Not all neural network architecture is really having these many parameters. So I'm talking about a particular architecture which is transformer, which is the most popular nowadays, and that also has a lot of limitations, issues, and scientists are working on replacing transformer with something else. But at the moment, we don't have anything better than transformer architecture. So it is trained. It is trained, and it is very intelligent. It is actually very large. You can see that somewhere 1 billion, 2 billion, 5 billion. So the model size is mentioned. So the largeness, the size, the largeness is all about it is working on how many number of parameters. So that is that number that is talking about 1 billion, 2 billion that we talk about. So in order to train those heavy models, we require supercomputing power. So transformer uses self-supervising. So that is again a way of the learning. So it's not like the supervised learning or not supervised learning, or reinforcement learning. It is a self-supervised learning that it is following. The transformer is following. So, and these modern LLMs that talk about the GPT, these are trained on billions. And now here I mentioned 1 terabyte, 1 TB of tokens. Okay. So that many numbers, that many numbers are used to train, or sorry, these are the tokens, sorry. So but they are trained on 1 terabyte of tokens. Okay, so that many tokens it is using, and then the data set is made of a billions of documents. So basically, when we look at the self supervised learning, it is actually learning from a huge data set, and that data set could be the books, online articles, website, code, etc. It could be anything. So it can do that self learning. It actually, the we don't need, nobody need to to sit and do the training, the training or the learning. It does it by itself. So now we get into the the core of it. It is basically why it requires. So the question is, we are talking about so much of computing power is required. You can look at this last point. Only supercomputing infrastructure can support this. But why what it needs to support, what is it really supporting? Then we need to understand how exactly this training phase is really working. So we need to understand that there is a forward pass, there is a backward pass, or I would say backward pass is something like a back propagation, the way it is trained. So like you just think about you are tuning a radio, like you are tuning for a particular station. Then what happens is, initially you are not getting the station, and then you slowly tune the knob, and then you slowly turn, and then you see that you are getting the station. Slowly you are getting, and there is a point where you will get the the station is becoming very clear. You are able to to get the voice so clear, right? I mean, that is how you basically tune the radio, right? So when you, from the earlier position to the current position of that knob, you understand that when you turn it, it actually you are setting that parameters. You are actually training. So you you are training the model by passing some parameters. First it was not trained, you just apply some parameter, it is not really giving the, in when I say trained, that means it is not really giving the result that it was expected. When you again tune it, and your model is again getting trained, but it is still not the expected, giving the expected result. But there is a point where you get the clear voice, and then you understand that it's actually matching that what you expect, and the prediction that the AI or the model that the prediction that the model done, that is also matching. So basically that value, or that knob turning, that parameters, that is actually becoming, or it is stored. And with that parameter, it can do the predictions in the future. So you are done the training, and then it actually learned it, the knowledge is now stored. So the next time the training phase is completed, now you are into the production. Now anybody can use, not really the training phase. Now you started using it, because all these parameters which is adjusted, and it is going to give the result. It will be able to to predict it well. So in the training phase, you will do that tuning, like a knob, and that is what happens in the forward pass. And when you see that you turn slowly and you did not get the result, then what happens is there is a backward pass, the backward propagation. Again, actually you are adjusting. So you didn't get the result that you wanted, and then you actually adjust it. So basically you are applying that gradient, or I would say there is a weight, you are actually applying. And then it again, that this cycle is continued. You do a forward pass, a backward pass, and in the parameters updated, and there is a point you get the result. So this is actually done thousands and millions of times, probably thousands of times. So internally it is forward the forward pass, or the forward propagation, or the backward propagation. And that has so many processes involved. So the forward propagation, um, so you need to understand there is a multiple layers for the there are multiple layers for the neural network. And you have the input comes into the input layer, and then it goes to, there is a layer where it is getting processed, which is called a hidden layer. And then hidden layer, from it is going to the output layer. So in this hidden layer, in every layer, the data gets passed on to the other layer, and then go to the other layer. So all that, the processing is happening in different layers. But basically during the training phase, actually you need to do that adjustment, which is nothing but the adjusting the values, which is called, you can see here, the parameters. So are the internal values, weights of the neural network, that get adjusted during training. And then you also have something called a gradient, tells the model which direction to move, which parameter to improve accuracy. So basically these values are added, and you actually make it adjust the training. And then finally you get a result. But the entire process, I don't want go into the details. So that's a problem. So I don't want get into the detail of this process: forward propagation, linear formation, activation. There are so many process internally. But this process is going to take a lot of resources, because it is actually applied on multiple layers, on multiple, I would say, and also getting applied for multiple parameters. It not just one parameter, it could be 1 billion parameters getting applied in different layers. And because of that, the processing is going to be highly resource intensive. And because of that, it requires a supercomputing infrastructure to support that training. Was it so complicated? Yeah. Anybody want to ask anything? So the idea was, to just talk about why we need the supercomputing infrastructure to train an AI model. That is what it all about. But how exactly it internally doing? That is the the way the neural networking is done. So it will follow all those processes, like as I said, the propagation that I talked about, the forward, backward, and the activation, the linear transformation, all the mathematical part inside the neural network anyway that will happen. But in order to do that, a lot of compute, a lot of resource is required, and that can only be provided by a supercomputing infrastructure. So the moral of the story is, in order to train the model, we require supercomputing infrastructure, and that is the relation of supercomputing with AI. Okay. Anyone has any questions before I just proceed? Okay, hope all good. So there are so many benefits. If you look at what the benefits of supercomputing, so it's again, see, if you it uses parallel processing, right? So if we can complete, if we are doing a parallel processing, and let's take any application, if you are able to complete it, then you can use it. So the accelerate time to market, it's a simple example that we can see as a benefit of supercomputing. So the calculation that generally takes weeks are completed in a fraction of time. So what will be the benefit? Like, see, if you completed that, if you don't need to wait for a week, so your processing is done, your system is ready, then you can consume it. So the accelerate time to market is one of the benefit of supercomputing. Similarly, as I already explained, the training large models, so that is also, that is also required, that you require the supercomputing clusters, the scale that we are looking for, the speed that we are looking for, um, that can be only be provided by a supercomputing infrastructure. So that's one of the benefit of supercomputing. Then research and innovation accelerated. So somebody is doing a research and innovation. So in order to trigger their innovation or in the research activity, you again, as soon as you complete your, training, so the research can be started. So how fast, the training cycles mean research can experiment, iterate, and innovate more quickly. So basically, it almost same as the first point. So the research can be started, like, if it is a drug discovery or a climate modeling that I talked earlier. So you can start it, if you complete it. Okay, so it is actually it's the same thing. And then if you look at the handling massive data sets, that is also like um, so you are talking about a huge data that are going to be used for training, and your supercomputer, look at, the storage architecture, network, all the core component that we talked about, that are required. And with that, you can definitely handle it. Is about, it's about the big data handling, right? So you can handle that big data only with a supercomputing infrastructure. So the handling of the massive data set, that is also a benefit of supercomputing. Okay. So now if we again go into the, the supercomputing, as we already see that, it's about, the massive computational power, parallel processing that we talked about, the storage, and, the workloads, the AI workloads. So these are all, and even the models we talked about, the LLMs, like, GPT. Um, those are basically the supercomputing, right? I mean, enabling training, support large scale deployment. What type of deployment we are talking about? Agentic AI deployment. What is that agentic AI deployment? We need to get into it. So, so basically, if this is all about the supercomputing, but in the left side, if you see, there are some of the applications, or how you are using this supercomputing in AI, and the best examples are generative AI, Gen AI, and agentic AI. So generative AI or Gen AI, it is all about, generating content. Okay, so we talked about, we look at, the traditional AI, which is telling like, okay, is it a cat or a dog? It will tell that, okay, this is a cat and this is a dog. Okay, so basically that's what, the supervised learning, where we train the model using the label data, and then, the system can tell us that, okay, looking at the photos or images, it will tell, because it is actually comparing with the, the trained data. Okay, so it can compare and say that, okay, this is dog or cat. But there, all what actually happening is, you are talking about the existing data. But when you look at the generative AI, we are talking about a new content. So think about a poet who is actually, writing a poem. That poem is completely new. It is not really something that existed before. So it is all about the generation. He is writing it. He created, or he wrote a poem. That's completely new, which never existed before. So that's all about, that is the same that, we are talking about the generative AI. It is generating the very new content, fresh content, and the content could be a text, it could be image, it could be code. So, but they are trained. Why it is able to do it? Because it's all trained. And who is actually generating it? It is the model, the large language model, or the brain of the AI, which is actually generating the text. That is nothing but that's nothing but, the predictions. So the AI is all doing the prediction. So all these contents are generated. It is newly generated, newly created, which is nothing but, the generative AI. And when we look at, the agentic AI, it is more of, generative AI is only generating the content. What if you need something above that? What if you want something beyond the generation of the text? Like, you ask something, and the system is, just responding with some content. But think about, you want the system also to do, or to connect with another system and do a task for you based on your prompt, your query. Then we call it as a agentic AI system. So the agentic AI system is basically, it's all about the agents, and that agents are autonomous. You can have, multiple agents. One agent is doing this task, one agent is doing another task, one agent is doing a third task. You take an example. I have a very good example that I'll just go to that. This is an interesting, the use case that we talk about, the agentic AI. And why we are talking about this agentic AI is because this agentic AI, all these implementations are are happening because of the supercomputing power behind. You have so many agents. Okay, I'll come to that. Okay, so you can see that, there are 5 6 different agents. Each of the agent is doing something. And what is this use case all about? It is automating the claim processing, fraud detection in the insurance domain. This is a working solution. We have it in IBM. We have it. Okay, so it was similar solution. It can do the fraud detection. It can do the the processing of claim. I mean the insurance domain. We have it, and we how does it work? Actually, there are so many agents, and agent is again what is an agent? An agent is a program, and a program having artificial intelligence. It is not a scripted program. It is not a simple program which is executed on the basis of script written, but it is executed based on the intelligence it has, or the intelligence we have provided to it. So when you are traveling from one place to, okay, you are started from home, you are going to airport, and on the way, okay, you have to reach there in 1 hour, and on the way you see that there is a traffic block. You understand that it is not going to, I mean, the traffic block will not be removed, and it will be there. Then if you stay there in the line or in the queue or the traffic, you are not going to reach on time. Then what you will do, you will basically, you will take a turn, you will take another route, you will go through another route, and you will reach your destination on time. So why we are doing that? Because you have the intelligence, and what you have done in before taking the deviation, what you really have done, you have done some kind of a reasoning. You have actually assessed the situation, and then you have taken a decision, you have made a decision that okay, so it's a just take a deviation, let's take another route and go. That's a kind of decision making. So it's all about the reasoning and the planning and executing that plan. That is what an agent with AI is doing, and that's why we call it as an AI agent. So the way that we thought, it's the same that an AI agent is doing. Okay, so basically you can have multiple that kind of agents, and then we can orchestrate all of them. You can correlate all of these agents, and then you can trigger that. So you will talk to the okay, there is a agent which is a kind of a supervisor, like a manager in the office. You will only talk to that supervisor, and the supervisor will divide the work, or to talk to the other people who are there in the underneath. So basically what happens is that, like, in these agents there could be one agent which is like a supervisor, and then you can talk to, you are actually telling that agent, to okay, I have these I want to process these documents for this customer. And the agent is responding that okay, do you have all the documents for the customer? Yes, upload it. Okay, then I uploaded it, and then it starts working. It actually talking to another agent which is going to do the policy validation. Okay, all the cross check the claim detail again, the customer's policy. Okay, is it meeting or is it a compliant? Then, and if there is any mismatch, it will flag it. Or if it is, and it also, once that is done, then the fraud detection. Okay, so it's checking all the anomalies detection. Okay, is it all looking at the claim history, any hospital records, accident reports, everything it will check. Okay, so basically it's not that the previous agent is doing it, there is a dedicated agent for that. And then there is an agent who is actually taking the decision. So aggregates the result from the previous steps, it aggregates it, and then finally it is actually handing over to the communication agent that okay, now everything is done, all your claim is processed. Maybe there are situations that the human or the automation um, requires some human intervention. So in order to do that, probably the communication will go to another a human who's part of that insurance company, that this requires your attention. Or it can do the if it is a simple claim, that it can approve by itself. So basically, and then communicate back to the user, or wherever it requires that communication. Okay, is it a user or to someone else, or maybe in an email, goes to an email, or it's going to a another system, which is kind of a CRM system, or I mean whatever. I mean the communication back to the user could be in any way. But my point is there are multiple agents, and each of the agents are doing certain tasks. And now all these agents, you have to understand, these are all autonomous. These are not really dependent on human intervention. It can all think, it can all do the reasoning, It can all take the or to create a plan, and it can all execute that plan. So they are all independent, and then having that intelligence to to do all these tasks. There could be situation that there's all this the planning, reasoning, planning, execution, that could be even go in cycle, that if it finds that it's not really the plan is not working, or if there is a if it doesn't meet the expected result, it can even do the reasoning again. It can again go back and do the reasoning and do the planning, replanning. So that is also possible. So basically it's very intelligent just like a human think. All these autonomous agent work. So if we can orchestrate all this and then make a system, and that's nothing but agentic application. So in order to if you look at the complexity of I just mentioned about our five different agents. There are scenarios where there are hundreds of agents or hundreds of thousands of agents running in parallel. Okay, so and each of these agent is dealing with so much of documentation, so much of data. Like we're talking about the insurance documents or images or medical reports or invoices, whatever. So there could be huge amount of data that it is going to be processed by each of these agents. And in order to to fulfill this kind of a situation, to implement this kind of situation, you are under the system that is underneath should also support and requires a high massive computation power, where also it comes the need for a supercomputing system. Okay, so that's a good example for for the agentic AI and how it is really used in the supercomputing with related to the supercomputing. Okay. Any questions?
Participants, please ask any question you have.
So
Anyone have any question?
So I
No,
do not
ma'am.
have any more slides. Yeah. So I do not have any more slides. It's more about very introduction part, right? I mean, I did not want to go into details, but at a high level, I don't know whether people got an understanding about where exactly if you look at the supercomputing again, where all it is really used and how it is really related to the artificial intelligence. Where are we using this, and why do we use this, and what are the real world scenarios that we are talking about? What kind of benefit that we are getting out of this supercomputing and AI? So these kind of things, that is the whole idea of discussion. So if you look at the overall picture, are you getting a sense of the supercomputing and AI? You might have already understood. You might be already knowing all this, but I don't know, right? I mean, since I don't see anybody in face to face, it's hard for me to to understand how you feel it. Normally when we take the sessions in the classroom, it is easier, like looking at the people, have an interactive, and then to discuss, it is more easier. So if you are okay, if you feel like it's understandable, you are getting a sense out of it, just tell me. I do not have any other points to discuss here. It's almost a 1 hour, but I would definitely want to discuss a little more about the MCP. Where exactly it is a very interesting topic in the AI world, or especially in the agentic AI world. But before I just go into that, because the time it's a 1.5 hour, right, ma'am?
Yes,
Yes,
sir,
sir.
sir. Till 8 o'clock, sir.
Yeah. So we have 30 more minutes, but yeah. So I can little bit talk about this MCP, because it's very critical part of the agentic application, which is related to the AI in the discussion today. So before we go into that, so is there anything that you want to ask? We can have that interaction and then we can proceed. If you don't have anything, I'll just talk about the MCP. What exactly it is MCP? Yeah, that's a buzzword nowadays in the MCP. If you look at the kind of applications every IT company is now focusing on. I'm sure even the students in the engineering colleges. I mean, all our colleges, they are working on the projects. The basically the academic project or what is it called? The other one. What was the other one? Academic project and internships, right? So when they work on it, I'm sure they are all using the AI extensions. They definitely use AI extensions, and they will give nobody is actually writing the code nowadays, right? So it is all about writing the prompt. You only need to know the English language. You write the prompt and you get the the code out of it, and even it can even create an application. So so the the chatbot or the AI extension that we use in our editors or the coding editors or the IDE, which is actually internally working as a agentic application. I mean, it's actually triggering an agentic application. So basically, if I just go back to some of the example, let's take an example of um, there is a company. Okay, so that company is actually um, it's a travel agency. It's a travel agency, and the travel agency, people come to the, just forget about all the AI and everything. So how the travel agency work, people will go and then they'll say that, okay, I have a vacation. I'm on vacation on this time. I want to go for a vacation. um, okay, so I want to go to the northern side of India, and then okay, let's say I want to go to Rajasthan, and then I have only 1 week. I'll give all my conditions. Okay, so the person who is sitting there, he or she will ask, okay, so how many days you plan to go for the vacation? Okay, what are the the interesting, what are the your personal interest? Okay, what type of hotel you really want to stay? I mean, you have any kind of a preferences? Are you in vegetarian or not vegetarian? What is your budget, etc., etc. All kinds of information they will take, and then they will make the travel itinerary. And once the travel itinerary, in the sense, they will go for the booking. Not just, they just don't stop by preparing, okay, having a itinerary. That is not what, they basically, they will get a confirmation that, okay, this is itinerary, are you okay, are you happy, okay, can I proceed? Okay, basically after that, they will go and the book the flight, they will book the hotels. There will be a lot of other things they will be doing. Okay, so now we'll look at the travel agency, how it is working. We can also think about, they can even, not we, I would say, the travel agency might think like, why would they come to me, why would they come to my office, or why would they call me? Why can't I give them an option that they can just enter their requirement the way they talk to me in my office? They can enter all these details into a chat interface, and my system will analyze it, this plain language, the natural language, whatever way they have entered. My system will understand it and do all the necessary action. If there is a requirement, to there is any kind of a confirmation needed, my system will ask the user back, and then they will confirm. And once the confirmation get, again my system will go and do all kinds of bookings, all kinds of planning, or whatever I have done can be done in an automated fashion. Why? What is the benefit of that? Because it's going to be a repeated, it's a repeated task. Because there's one customer, there's a second customer, third customer, all they will all do the same thing, and it's a kind of a repetitive task. I can automate it. I can automate it efficiently. When I say automate it, automation is also there, in the long back, it's all kinds of automations are there, but those are all scripted, they are all programmed. There is a if else kind of thing. If you do the, if this, do this, else do this, else do this, like that, right? So basically it's all scripted, it's all functionality programmed way. But not, that is not what we want. It needs to, think like a human. Like, the budget is 20,000, but looking at the flight ticket, it is actually exceeding 20,000. It is going to 25,000. But you need to, what will happen if the system, it's a scripted one, if it is a predefined logic, then it will not proceed. But if it is a human, then he will come back and ask us, sir, it's actually your budget is a little bit exceeding. It is not available for 20, but it is available for 25,000. Okay, are you okay with this? Because this is the only available, rate we have currently. Then you take a confirmation. The customer will say, okay, yeah, so okay, if it is not available, just go ahead. Okay, that confirmation, then do it. That's a way of human thing, right? It's all about the reasoning. It's all about the planning, right? And then take the decision, right? So that kind of a reasoning, because it's not actually, it's all about goal oriented. It's all about the goal oriented approach. So what is your intention is, to do or create a itinerary, create an itinerary, and then book the tickets, complete the entire, process of booking, right? So that is the goal, not to stop somewhere. Okay, so it's a very much, reactive way. It's a kind of, you are working in a goal oriented way. It's same like, onboarding an employee in a company. Like, if something, when I say onboarding an employee, there are so many steps involved: giving them training, provisioning their computer. There are so many steps, not just, somebody came in and, I entered their name and it's done, or maybe I'll just send an email that, onboarding is completed. That's not the way, right? There could be many challenges might happen in between, and all that needs to be handled just like a human, and then complete the onboarding process. So basically, these are some of the areas where agentic application comes into picture. Now, when I come into the MCP, why I talked all these stories, because when I look at the travel agency where you need to book a flight ticket, you cannot simply do that. Your system has to talk to the airline company, or the airline system, and that interfacing. So you are going out of your application into somewhere external, where it is connecting to book the ticket. That kind of external communication from your application can only be done through an API call or application. It's an external call. Basically, you require some kind of server or a service which would actually do that communication with the airline or the external source, and that is nothing but that MCP server, where it's actually a model context protocol. It's a server, MCP server. It's a server, not really a physical server. It's an application, just like a HTTP server, FTP server. It is a server, MCP server, which is actually enabling you to communicate with an external source, whether it is an airline system, or whether it is a kind of other system on an Oracle database. It could be, different other, it's a GitHub, or anywhere, or a Salesforce system, anything. It actually allowing you to communicate, or enabling you to communicate to an external system. And that, how it is allowing that, it is actually exposing all the capabilities of that external system in its MCP server. So whatever capabilities are there for that external system, let's say Oracle, or maybe I'll take a, that airline system. That airline system has some kind of a way to book a ticket, or to do the payment. Those are all the capabilities that we would require to know in order to make that booking. There could be a way that, it might be taking some input, like a date and the location, that the destination, and so that it can give all the list of airlines that are that are going in that direction on that day. That will be listed. There will be a list provided. So list all the airlines available based on XYZ parameters. So that's a kind of a capability that would be exposed through this MCP server. So this is a very interesting concept, because the same capability can be used by anybody. Like, I am developing an application, I need all this. There is another person, he's also developing something, they also need to talk to that airline. They can also use that server or that interface. So basically it's a kind of a, if we don't have this, what will happen? I need to directly talk to the airline, he also need to talk to the airline. We both need to have that integration or the implementation to communicate with the airline system, and do the booking, payments, etc., etc. So here it's a common interface or a common gateway where everyone can talk, and the gateway will take care of the rest of the the activities, like the authenticating, or to get list or get all the airlines, or enabling the payments part. All that can be done with this MCP server. So it's a standard way, and that's why it's basically, when we look at the agentic application, it's a kind of a standard. When we look at MCP, model context protocol. So it's protocol. When we look at the protocol, it's a rules and regulations, or the different rules and the regulation that you need to follow when we are talking to the MCP server. So everyone needs to follow, whether it's me or him, has to follow a particular standard to communicate with the MCP. Or in other words, the MCP is actually forcing us to follow a particular rules and regulations. That's what actually happened, so that we both can communicate with that external source, external system seamlessly. That's an interesting fact of MCP. So in the agentic application world, MCP is nowadays, it's an unavoidable technology used throughout. So we can even have more deep and research on what is MCP, how we can create an MCP, who is using that MCP, what kind of capabilities we can provide. So the capability is basically tools and resources. I'm not going to that detail, so I'm just giving a high level way that we call it as a capabilities. But capability is, it's actually divided into two different areas. One is a tool, one is a resource. Okay, so it's actually internally using the tool to make a call to the external source system. So this is an interesting area that we can even explore, and because it's all about FDP, right? I mean, development program, right? I mean, just thought of, we talk about all that interesting areas which can be even added in our curriculum when we going to the coming years. We can always refine our curriculum with all the the latest trends, right? So this is very interesting. And the other part, I think I already talked about the agentic application. I talked about the orchestration. I just mentioned the example, like the Langflow. IBM also has an orchestration framework. I don't know whether you have heard about it, the Watsonx Orchestrate. So that's a kind of orchestration similar to any orchestra the the music world. We have orchestra, right? Similar to orchestra, we have an orchestration. Any questions by anybody? I see that is somebody unmuted.
Requesting the participants to Sir, kindly proceed. It was accidental, I think. Sorry for that, sir.
Sir, I think it's not audible. Sir, it's not audible.
So it's not audible.
Praveen, sir.
Hello, am I audible now? Am I
It is
audible now?
audible. Oh, it's audible now, sir. Sorry.
Okay.
Okay.
Someone, I think it's someone muted me.
Oh,
Okay, that's fine. Okay,
okay,
anyway.
okay, sir.
Okay. So, okay. So what I was, 1 second. So, am I sharing the screen now?
No, sir. The screen is also not shared right now.
Okay, okay. But I think I actually I have covered all the the topics that I want to discuss. So, any questions anybody has, because the way we interact face to face and the way interact over the the virtually, it's a totally different, right? So if you have any questions, anybody has any questions, we can discuss further. So I think I actually talked about all the supercomputing, the introduction part. I talked about how it is really useful in the AI world, and what type of AI are we talking about. And the byproduct talk is basically what is the latest trend in the AI, because all this computation power that we look at, the in whether it is I don't know whether you heard the last sentences that I said. Basically, if you look at the cloud, the Google or Amazon or or Azure, the Microsoft, so they all have very large scale infrastructure behind. And then because of that, they were able to to provide all kinds of services, like the AI services that I talked about. Then the Microsoft, there's something called the AI found, the AI, I sure AI Foundry. It's a foundry, is nothing but the AI services that they offer. Even the AWS has something called a Bedrock, which is actually a AI service that they offer. So basically, all that AI capabilities that they are offering, and it is all working because of the huge infrastructure that is underneath their cloud. So their basically their core infrastructure that we are talking about, not the virtual server. I'm talking about the physical infrastructure that is behind all this cloud. They are able to do it because of the supercomputing power that it is offering. Okay, so we have almost reached the, I mean, it's I think it's on time, I guess. It's 8:07. If there are no other points, I think if you have any other questions, or is it understand, is it clear to everyone? I know everything is clear, there are no questions. That is the case.
Hello.
Otherwise, I feel like I have done with my presentation.
Any questions from participants? Participants, please
Is there
interact.
anything in the chat? uh,
No, sir.
okay, I'm looking at the chat. Okay, you have any questions? Okay.
Any questions from the audience? Or kindly put it in chat so that we can request a resource person to answer your queries.
Okay. I hope it was clear to everyone. At least they got some sense of supercomputing and AI. So people can definitely to explore more. It's a kind of introduction, right? So we can always go and explore and then learn more. Yeah, the same way I'm also doing. Thank you so much.
So if there are no questions from the participants, I think coordinators, you can.
Okay. Okay. So a heartfelt thanks to you, sir, for delivering such an enlightening sessions on supercomputing and its transformative role in AI and HPC. And your expert insights on the architecture, applications, and this future of supercomputing have greatly enriched our understanding of this cutting edge field. And from HPC systems providing complex simulations to enabling breakthroughs in AI through LLMs and neural networks. Your explanations highlighted how the supercomputing is revolutionizing science and technology. So we are truly grateful for your time, expertise, and passion in sharing this knowledge with us. So thank you once again, sir, for your incredibly informative and inspiring session. Thank you once
Thank you
again,
so much.
sir.
Thank you.
There is a 5 minutes break before the second session. Participants, please wait.
Please keep joined in the meet itself so that we can start with the next session. So, but we can take a 5 minutes break in between and we'll be starting the next session accordingly. Please join back on time. Coordinators, please stop recording and start a new recording.